Okay, sixth grade, our objective today is to talk about mean, median, mode, and range. I also want to spend a little bit of time reviewing the roles of adding and subtracting and talking a little bit more about types of numbers. The homework that you just turned in, I will grade today and get back to you tomorrow, so if you miss anything, you will have an opportunity to make corrections again. Next week, I'd say the middle of next week, you are going to have a Chapter 1 test. So remember, you were not quizzed on this chapter because it was pretty much a review chapter. Every other chapter, you'll have 1 or 2 quizzes. Okay, so your first real test will be the middle of next week. I'll let you know tomorrow for sure what day that I think that's going to be. Sean? Yeah, we'll review. I will give you a written review, and we'll do some type of review in class, which I'll talk more about next week. Yes. Jeremy? You mean the chapters? Yes. Chapters have every chapter has about 7 or 8 lessons. No, that's way too many. No, not 15. The reason is I supplement these lessons and they'll eventually get to be harder and there's more material in the lessons. So that's why I like to keep it between 7 and 8. Annalise? Well, we're not done yet. This chapter goes up to 8. But today's lesson is an extension. Sometimes I add on extensions of other lessons. All right, so let's go over the warm-up. So can someone remind us, when you're adding integers and it's the same sign, what do you do? Alyssa? Good, add and then put the sign in front. If you are adding integers and one is positive and one is negative, what do we do? Briar? Close. So you're adding, the signs are different. You know, good job. Subtract them, take the sign of the larger number. When you're subtracting, what do we change all subtraction problems to? What do we change all subtraction problems to? Matt? Good. All subtraction problems we change to adding the opposite. Adding the opposite. From there we use our addition rules. If you have 2 negatives back to back, what does that become? 2 negatives back to back, Annalise. Good. A positive. In your own words, what does absolute value mean? In your own words, Charles, what does absolute value mean? Good, distance from 0. Is absolute value ever negative? Mary? Good, no. Now, if they put a negative in front of it, that's a completely different question. If you take the absolute value of a number, it's never negative, it's always positive. Okay? A natural number starts with what? Natural number, Alyssa, starts with what? Good. Is 1.1 a natural number? Nope. Natural numbers are nice. They go on from 1 all the way up through infinity. They're nice numbers. What is an integer? What is an integer? Emma M? Good. Explain a little more. Good job. What is a whole number? What's a whole number, Justin? Good job. What's the difference between a rational and an irrational number? What's the difference between rational and irrational? Doug? Okay. Good. So there's one word I want you to say. What's that word I want him to say? You're right. Alyssa? Good. Pi is irrational, and there's another word. I should have said 2. Mary? Good. E? You guys are so interested in E. Good. There you go. That's the other word. I wanted to hear pattern. Rational numbers always have a pattern, or they are a nice decimal, such as 4.3. Irrational numbers do not have a pattern. They repeat however they want. That will be part of your test next week. Annalise?
Wait, what do you mean by a nice decimal? Do you mean
like 4.3. It's only to the 10th place. No, it can be to the hundredths. Yeah, it can't just be going on forever without a pattern. If it goes on forever, it has to have a pattern to be rational. That's not for a long time. They were asking me about it maybe that was a week or 2 ago. Annalise, I don't think you were here when they were asking. It's basically it deals with a logarithm. and a natural log. You won't learn about that until the end of Algebra 2 and trigonometry pre-calculus. So if I talked about that, it would take all class, which we don't have time for. Mary? Yep. Yeah, that's a good analogy. That's a good analogy. Yeah. You'll see what it's used for and what it really looks like eventually. Okay, so warm up. Number 1, Justin. Good. Doug, number 2. Good. Matt, number 3. Good. Number 4, Alex. Good. Emma M, number 5. Good. Jeremy, number 6. Good. Number 7, I think I need to move to the next page. Okay. Number 7, Alyssa. Say that again. No, not -3. And not -6 either. I started to write the answer. Add the opposite. Okay. Emma H, what did you get for number 7? Nope. Add the opposite. Add the opposite. Charles? Good. Be careful on subtraction. Always add the opposite. Donatus, number 8. Good. Number 9, Mary? It should be 164. Yeah, 164. I was like, wait a second, did I add wrong? Yes, you may. The electric one is right over there. Adam, number 10. Good. Number 11, Emma M. Good. Zach, number 12. Okay, what'd you get for 13? Good. Okay, let's go back to number 12, Briar. Good, -170. Sean, number 14. Yep, good job. Annalise, number 15. Great job. Alex, I know you came in late. Did you get to number 16? Okay, just tell me what you got for 16. Good job. Matt, 17. Good. 18, Justin. Good. Doug, 19. Okay. Emma H, did you get to 19? What'd you get? Good job. 20, Alyssa. No, I think maybe you might have forgot about those 2 negatives back to back as a positive. It's the only thing I can think about. Mary, what did you get? No? Jeremy?
39.
Good. 21, Donatus? Good, -9. These ones are hard. 22, Adam? Good. Charles, 23? Close. You have two of your numbers mixed up. Alyssa? Good. -742. 24, Emma M? Great job. Okay, now listen. We're moving on. So, what problems on here are you confused with? Do you need me to go over? Because on the test, this will be the no calculator part. Yes, they will be similar to these. The numbers probably won't be as big, but the problems will be similar. Doug, we'll start with you. What number? Okay, give me one that you got wrong. Why don't you look at your paper? Do you know which ones you got wrong? Okay, well then, here's what you need to do, Doug. If you didn't get any wrong, you need to do them. And then if you get them wrong, ask me tomorrow. Okay. Okay, we didn't even get to multiplication yet. It's minus a negative. 2 negatives back to back is a positive. You could also think of it as subtraction is adding the opposite. So you have 112 plus 52. All you do is add the numbers. They're both positive. Keep the answer positive. So let me say that again. Subtraction is adding the opposite. So you would change this to addition, and then the 7 will become positive. You can also think of it as you have 2 negatives back to back. They always turn to a positive. Yes, it is. Yeah, we're not doing multiplication. Multiplication's either tomorrow or Monday. Okay, we're adding and subtracting. Minus a negative is always plus a positive. Okay? Hopefully you did that on your homework last night. It's always minus a negative is always plus a positive, or you could say two negatives back to back always becomes a positive. No, you have to add. There's two negatives back to back. So you just always need to tell yourself, Doug, when there's two negatives back to back, it becomes a positive. Okay? All that is back in your notes. If you need to look back in your notes, we have a lot of examples like that. Add them, make the answer positive. Matt? All right, 21. Okay, number 21, the first thing we need to do is order of operations tells us to add, subtract from left to right. All right, Matt? So 81 minus 165. Did you change that to adding the opposite? Okay, so now we subtract, which is 84. Take the sign of the larger number. Okay, but you still should, hold on. And then rewrite your minus negative 75. What did you get for your answer? Oh, okay, you were only off by 1 then. So you know what you were doing. You know what you're doing. It was just a small mistake. Okay, that's that. Change those to a plus. Subtract the numbers, which is 9. Take the sign of the larger number, which is negative. Okay, any other ones, Matt? Okay, Mary? Okay, so let's start with 17. 17 is the additive inverse property. What did that additive inverse property say? What was that, Justin? Yep, good job. When you're adding opposites, you always get 0. So on 17, we have negative 231 minus negative 231. You are adding the opposite, which you could also say two negatives back to back is a positive. So we really have negative 231 plus 231. Okay, instead of subtracting them. Yeah, when you're adding and there's opposite signs, subtract them, put the negative in front. Okay, Annalise. I'll go back to that. Okay, hold on, okay, 21 I just did. Did you see me do number 21 for Matt? Okay, let me do 20 for Mary, and then I'll re-explain that one quickly. Mary, 22. You said number 20 as well. Okay, number 20, negative 85 minus negative 106. We have two negatives back to back. So first thing you need to do is change those to a plus. Did you do that? Okay, so we have negative 85 plus 106. You're adding, there's opposite signs. Subtract the numbers, we get 21. Well, then you just subtracted wrong. You should have done 106 minus 85, which is 21. Okay, maybe that was just a weird mistake. I'm not quite sure how you got that. Drop down the plus 81, or plus 18. You're adding and they're the same signs. Add them, keep the positive in front. Mary, I think maybe you just looked at the number wrong. Or you did number 21 for number 20? Something like that, maybe? Yeah. Just what I would do is ignore what you did. Don't try to figure out what you did wrong, just because you think you looked at the wrong number. Just make sure you understand what I just went over with you, and you should be fine. Okay? Anyone else on number 20 before I go over 21 again? Okay, so Annalise, for 21, the first part is a subtraction problem. So change all subtraction problems to adding the opposite. Okay, did you do that? Adding the opposite, you now have two numbers you're adding, the signs are opposite. So you need to take 165 minus 81, bless you, which is 84, and then take the sign of the larger number. The larger number is negative 165. Make the answer negative, because the larger number is negative. Okay, so we changed it to adding the opposite. So when you're adding and the signs are opposite, you need to subtract the numbers. So 165 minus 81, you have to subtract them, is 84. And then take the sign of the larger number. The larger number is negative, so the answer has to be negative. and then drop down minus negative 75. Just drop that down, and then you're subtracting. We are really adding the opposite. You could also say two negatives back to back is always a positive. Does that help? And then at this point, you're adding, the signs are opposite. Subtract these numbers, make the answer negative. Okay? Okay, what other one? 13 you said? Okay, pick one of those. $19? Okay. All right, 19. So first part of this, we are adding their opposite signs. So when you're adding and there are opposite signs, we need to subtract those numbers. Okay? So we get 11. Take the sign of the larger number. The larger number is positive. So 11 stays positive. You with me on that first part? Okay, and then drop down the minus 60. So since we're subtracting, we are really adding the opposite. Since you're adding the opposite, subtract those two numbers, take the sign of the larger number. So 60 minus 11 is 49. The 60 is the larger number, it's negative, so the answer is negative. You okay with that? Positive? Okay, when you change this to subtraction to adding the opposite, you really have negative 23 plus 28. Since the larger number is positive, your answer is positive. You do 28 minus 23. Always take the bigger number minus the smaller number. Maybe that's why you messed up with some of those. Always take the absolute value of the numbers and take the big number minus the smaller number. Okay. If there's any other questions, let me know either later today or tomorrow when you come in. Annalise? 7? Okay, so what I need you guys to do is take out your notes, open up to page 19, please. And after your notes are out, open up to page 19. I need to see thumbs up, thumbs middle, thumbs down on adding and subtracting integers. We're not done with practicing, I'm just curious. But I didn't grade your homework yet. I think I'll know after I grade it. Okay. Emma, are you in the middle? Is that why you're doing that? Okay, thank you. All right, so we are going to talk about, for about 10 minutes or so, mean, median, mode, range. I want you guys to have some time to start homework in class today. So does anyone have any idea what these are? You don't remember? Okay. Okay, so let's start with the question, what are these, Jeremy?
Well, mean would be adding all the answers up.
Yep.
And then dividing them by the amount of numbers.
Perfect.
Mode would be what's there the most.
What occurs most often, good.
Range, take the biggest and smallest numbers.
Good.
Median is
Good job. When might we use something like this? Well, what's like an example, even if it's just for one of them? Adam, when might we use this? Yeah, for any kind of statistic. Maybe you're analyzing something. You need some statistics. We need to compare it with something. So that could be for a lot of things. Exactly right. Briar? Good. Anytime we take a test in here, I always figure out what the average is, and then I'll compare your grade to the average as well as the average from the previous year. So I always like to see what the average is. Typically, the average for tests in this class is either a B+ or anywhere in the A range. You guys are 2 years accelerated, so test scores are normally pretty good, even if I make them hard. Sean? Good job. Good. So anything with sports, great. Keep track of your records. Maybe you want to find the mean of that, or even the mode. Mary? Yep. Yep. You're exactly right. So there's a lot of things in life that we can use these for. Now, let me explain this. The book adds a word into mean, median, mode, and range, and so does the Algebra 1 book. Central tendency is a word that's kind of like the umbrella or the top of all of those. There are 3 ways to measure central tendency. and that's mean, median, and mode. Range is a measure of dispersion. So 3 measures of central tendency are mean, median, and mode. Annalise? I'm going to explain that. Okay, so first one is mean. So mean, which is one of the measures of central tendency, is an average of a numerical set. So just jot down on that line that mean is an average of a numerical set. Now, this is probably new to you. I'll wait till you guys write that down and I'll explain. So average of a numerical set. And I'll explain this symbol once everyone's done writing that. Okay. Symbol for mean is X with a bar on top. So the symbol for mean, which is another word for average, is X with a line on top. Does anyone know what all this stuff means? What is all this? What does that mean? It does mean something. Doug, what do you think? Good job, they are. Yep. So all this means is you take the amount of values there are in the set, divide by n. N is the amount of x's or numbers there are in the set. So n on this example, yes, it goes on forever, but it's not always going to go on forever. When you're finding average, add up how many things there are, how many items there are, divide by the amount that there are. Bless you. Remember this symbol, X with a bar over it, always means mean, which another word for mean is average. Annalise. You can just write down the symbol. That's not really an example. That's just what the symbol means. But you guys, for this class, you just need to know the symbol. You don't have to write that down. Doug. At the top of the paper? Yeah, that's something that's optional. You guys can, but you don't have to. Mary? Subscripts? Definitely, yes. Okay, any other questions on that? Okay, so 2 other means of central tendency. Let me cross this off. Only write what I did not cross off. So median, as Jeremy told us, is the middle number when the values are written in numerical order. So median is the middlemost number when the numbers are written in numerical order. Now, here's what I crossed off. Don't write that. I crossed off that if the data has an even number of values, you need to take the mean, which is the average, of the middle 2 most numbers. Yep, so I'll say that again. If there's an even set of data points, you take the middlemost numbers, you add them, divide by 2. If there's an odd number of data points, it's really easy because all you do is take that middlemost number. There's only going to be 1. And we're going to do an example so I can show you guys that. So the median, if there's an odd set of data points, it's easy. If there's an even set of data points, you have to find the middlemost numbers, add them, divide by 2. Mary? Just take the middlemost number. Yep, and that happens sometimes. Yeah. Annalise. Yep. The thing that I crossed off, you mean? Don't write that down. We always will do examples. Yeah, we're going to do examples which will teach you that. So don't write that down. Doug? No, we're going to stay on task, okay? Not right now. Okay, next word, next term is mode, which also Jeremy told us this as well. The value that occurs most frequently. The value that occurs most frequently. There can be one mode, there can be no mode, and there can be many modes. So mode, the value that occurs most often, there can be one, none, or many. Mary. Exactly right. Yeah, very good example. Yeah, mode, and I know a lot of you guys have already learned these, but typically when you hear this for the first time, as Mary said, you always think of mode as most, the number that occurs most often, because it's MO, just like Mary said. Median, think of the median strip in the middle of a road or a highway. It's always in the middle, just like median is the middlemost number. So those are, yeah, great analogies if you don't, if for some reason you don't remember that. And then mean is always average. So just remember mean is always the average of the data set. Emma M? No, I'm going to get to that. So these are 3 measures of central tendency. I don't want to get into too much as to why they call them that because that's more of Algebra 1. But basically they'll ask you in a data set which 3 of these terms is the best measure of central tendency, which means which one is the best representation of the data. So let's say maybe the average of a test in this class is a 91%, but maybe the mode is an 85. Well, I'm going to use the average, which is the mean, because that shows off your test scores better than the mode. So depending on what the data is, they'll pick one that best measures that data for what they're using it for. And the measures of central tendency is more so an Algebra 1 term, but I still like to tell you when we talk about these, so you know that's what they're categorized under. Mary? Exactly. Good job. Have you guys all learned about outliers? Okay. An outlier, real quick summary of it. An outlier is a number that's just sitting by itself. It has nothing to do with the other numbers in the data. So it's just kind of hanging out by itself. It's either a lot bigger or a lot smaller. So if someone gets a 12% on a test, but everyone else gets into the 80 or 90% range, that's a big outlier, which is not going to happen in this class. But that's one example of an outlier. Annalise? Okay. Cool. Okay, one more definition, and then I want to do 2 examples. Okay, so range is a measure of dispersion. You don't need to write that. But what a measure of dispersion means is it describes the spread of the data. So you don't need to write that, but what range is, it describes the spread of the data. Range is when you subtract the largest number minus the smallest number. So it's the difference between the greatest value and the lowest value in a data set. Charles.
Median and mode fall pretty much.
They'll be very close. Yes, and that's also a huge Algebra 1 discussion, because you will get some problems where the best measure of central tendency could be 2 of them instead of just 1 of them, because they're so close that 2 of them could best represent the data. So yes, great job thinking outside the box there. Yes. Okay, so again, range is a measure of dispersion. In trig pre-calculus, you will learn about some other terms that also mean measure of dispersion, such as standard variation, okay, and standard deviation. Okay, so let's do an example. Okay, we need to find the mean, median, mode, and range of this data. Before we do that, what should we do with the data set? Charles, what should we do? Yep, let's put them in numerical order. So we have 1,000 is the smallest, and there's 2 of them. So I want you guys to write down 1,000, 1,000, cross off as we're putting them in order. That way you don't make a mistake. Donatus, you should be with us, writing them in order, okay, from least to greatest. Second number is 1,081, 1,181, sorry. Next one is 1,191. Next one is 1,200. Okay, next one is 1,268. Next one is 1,328. And then the last one is the one that's 2,000. So we have 2,584. So make sure they are in order from least to greatest. It'll save you some time and some frustration. Okay, we now need to find the mean, which is the average. I want you guys to take your calculator, add up all the numbers. When you think you have an answer, put your hand up. So take those numbers. I want you to add them all up. You okay, Jeremy? Okay. When you think you have an answer, put your hand up. Okay, Alyssa, what'd you get? Who agrees? She's right. Good job. 10,752. So that's the sum of all of the values. What do we have to do with that number to find the mean? Zach? Good. How many numbers are there? Good. We are dividing by how many data points there are or how many numbers there are. There are 8. So next step, go ahead and divide 10,752 by 8. Emma H? Good job. So the mean of the data is 1,344. Mary? Well, then you probably just missed a number. I promise you it's 10,752. Be very careful when you're typing them in. I'm sure you just hit a button incorrectly. On a test, I would do it twice to make sure that you're typing it in right. Okay, just because the numbers on here are somewhat big as well, so it tends to be a little tricky sometimes. Okay, the median. It's the middlemost number. There's an even set of data points. How do you do that if there's an even set of data points, Annalise? Good job. So I'm going to circle the middle two most numbers. So circle those middlemost numbers. We need to add them. So 1191 plus 1200 divide by 2. So order of operations tells us add the numbers in the numerator first and then divide by 2. So what is 1191 plus 1200? Let's start with that. So 1191 plus 1200. Doug? Good. 2391. So add them first. Okay, what's the median? Keep it exact. Jeremy? Good job. And keeping it exact, I mean, is do not round. So keep it exact. So not bad, right? Take the middlemost numbers, add them, divide by 2. Okay, what about the mode? Remember, there could be no mode, there can be one mode, there could be many modes. Justin? Good. And the mode is 1,000. Justin, why is that the mode? Yeah. Good job. 1,000 occurs most often. It's listed there twice, so that is the mode, the number that occurs most often. Jeremy? It won't be. Good question. It won't be. Great job thinking, though. It won't be. Okay, Doug, question? Okay, hold on. Okay, so range is taking the largest number minus the smallest number. So we have 2584 minus 1,000. So you're just finding the difference of the largest minus the smallest. When you think you know what the answer is, which this one should be pretty easy, put your hand up. Sean, what'd you get? Good job. Doug, did you get that? Good job. So thumbs up, thumbs down, thumbs down on that example. And if you're in between, like a top and middle, that's fine. Okay, thank you. Any questions on those 4 terms? Okay, I wanted to do one more example, but I'm going to skip this one for now. We'll do that tomorrow. I want you guys to take a look at the closing. So here's kind of an interesting application where we are not just looking at numbers. So besides this being, I think in your notes it says moths instead of months. Anyways, it should say months. Oh, never mind. It does say months. Okay. So the closing says 10 Colorado ski resorts have scheduled openings in the following months. Find the mode of the data. So they have openings in all these months. What's the month that has the most openings? Which means, all right, well, what's the mode? What's the mode, Briar? Good, November. Why is that the mode? Good. Good. So that's their popular month. That's the month that they have most of their openings. Well, that's the beginning of ski season, so everyone's probably excited to get ready and go skiing, right? Oh, cool. I like skiing too. So anyways, I wanted to show you this because finding mean, median, mode, and range, in this kind of example, you could find the mode of months. Okay, it doesn't necessarily have to be just numbers all the time. Okay, any questions on mean, median, mode, range? I don't. Well, you could, yeah. You could just to find, okay, well, what is the average month? But it's much more applicable if we had numbers for that. Now, we could also find the median here if we put them in order. What's the middlemost month? But that's kind of stretching it. But we could. Yeah, we could. Basically, the mode is the easiest to find if it's not numbers. Yep. And that happens a lot where some of them are the same, especially if the data is really close together, whether it's names of things or numbers. Jeremy?
Maybe if it's like October and November, it could be October.
Yep. Yeah, could be. Doug, hold on one second, okay? All right, so I'm going to change this a little bit. I need everyone to open up your homework packet to back of page 19, so back of your warm-up. Actually, forget about this. Okay. Okay, so back of page 19, it looks like this. back of page 19. Now listen carefully because some of you guys yesterday did not listen in regards to your homework and you didn't do it correctly. Here's what you need to do. So underneath number 1, I want you to write down X with a bar over it equals MED, which stands for median, equals mode, equals range, equals. Underneath each of those problems, I want you to write just what I did. Above or under each of the data sets, please put the numbers in numerical order. You may use your calculator on this. Some of them are decimals, some of them are not. If you need to look back in your notes, that one example is enough because you also have the definitions there. Okay, so I'll say that one more time. What I wrote on the board needs to be under each number. You also need to put the numbers in numerical order, from least to greatest. So only 13.6, 1 to 7. Okay, did everyone listen to the homework directions? Because that has been a problem the past couple of days for some of you guys. Okay, any questions? Okay, let's hope both buses are there. Once you're done writing that down, go ahead and get packed up. Good job today. Is it that? Yeah. Yep, 13.6. You're good. Thanks for checking.